Welcome to today's lesson. We are going to look at experimental probability in single-step experiment. In our previous lesson, we've been looking at theoretical probability in a single-step experiment, and whereby we said in theoretical probability, we are expecting there is that exact figure that is expected, or that exact chance that is expected. So that exact chance that is expected is what we were referring to as theoretical probability. But in this case, we are having an experimental probability. From the term experiment, it means we are going to carry out an experiment, then out of that experiment, we work out the probability of an event happening. For instance, in democratic countries, you discover that they vote for their presidents, and when during that electioneering period, there are some people who come up with an experiment. They conduct an experiment in a given group of people, finding out which president do you think is going to win and which one do you think is going to lose. So in the process, they come up with data, and from that data, they work out the percentages of each and every president that is expected. Alternatively, what happens in life, in real life, is this. When a woman is expectant, then we are having probability of getting either a boy or a girl. So whatever is being expected is, we can carry out a research in a given society and find out what is the probability from these families. How many boys do we have? How many girls do we have? You can go ahead and carry out from another family, find out how many boys are in that family, how many girls are in this family, then carry out the probability and find out what is the probability that the child that is going to be born will be either a boy or a girl. So with experimental probability, you are going to carry out an experiment. You are going to carry out a research on a given activity. Then from that experiment that you've carried out, you go ahead and work out the probability of the expected outcomes in each case. So we can simply go ahead and tackle some few questions on experimental probability. But before we work out the questions, we need to find out how do we get probability of an event happening when it comes to experimental probability. When we are talking about theoretical probability, we said that probability of an event happening is given by the number of favorable outcomes over the total number of outcomes. But now this is an experiment that you've carried out. It is not theoretical. It is now an experiment. So how do we get the probability of an event happening? So probability of an event happening is obtained by the number of times the event occurs over the total number of trials. So we are having the number of times the event will occur divided by the total number of trials in that experiment. So for instance, you are having maybe a group of 10 families. In this group of 10 families, you want to find out how many boys and how many girls are there in these 10 families. So the first family, you find that this first family has 2 girls and 1 boy. In the second family, you find that in this second family, it has 1 boy, or let's say 1 girl and 1 boy. In the third family, you discover that this third family has maybe 2 girls but no boy. In the fourth family, you carry out this experiment and discover that in this fourth family there is no girl but we have 1 boy. In the fifth family, we discover that in this fifth family we are having 3 girls, then we have 1 boy. The sixth family, you carry out a research and find out that in this sixth family it only has 3 girls. Then in the seventh family, you discover that the seventh family has maybe 1 boy but no girls. Here this is 3 girls and 0 boys. Then next, the 8th family, we have the 9th family, then we have the 10th family. In the 8th family, we discover that we are having 4 girls and no boy. In the 9th family, you discover that we have maybe 2 girls and no boy. Then in the 10th family, you discover that this family maybe has 0 kids and so on. So what happens is you want to find out what is the probabilities of either having a boy or a girl in that given family. So you've carried out a research and you found that in total you have these boys and girls in each and every family. So we need to find out what is the probability that if I pick on any family, I will have a girl. What is the probability that if I pick on a family, I'm going to get that child that I've picked will be a boy. So that will mean you will have to get the totals of whatever trials you've carried out. You will have the total of girls, get the total of boys, and get the total of all the kids that you have. So the total of all the number of children in these given families will give us the total number of trials. So you've gotten the total number of trials from the total number of children you will get in this given family. Then we need to find the event that the probability of getting a girl. So probability of getting a girl then will be obtained by the number of times the event occurs. The number of times these girls occur in this given experiment that you've carried out. So you find out how many girls have occurred in this experiment over the total number of children we have in this given experiment. So this will be called an experimental probability. So we look at some few questions involving experimental probability and try and see how we tackle the questions. So the first question, So we have the first question. A 6-sided die is rolled 10 times and the following numbers come up. The first time the die is rolled, we have 2. The second time 4, 6, 4, 5, 1, 6, 4, 4, and 3. So those are the numbers that are showing up when the 6-sided die is rolled 10 times. So the first question is, what is the experimental probability of getting a 3? So we are getting the probability of getting a 3 in this given experiment. So we find out in our experiment how many times has the number 3 occurred, or how many times has the number 3 shown. So we find the number 3 and we discover that 3 has only shown once. So since 3 has only shown up once, we say that the probability of getting a 3, the experimental probability of getting this 3, will be 1, which is the number of times the 3 has shown in the experiment, over the total trials, total number of trials. The total number of trials were 10. So we find the probability of a 3 showing in this experiment will be 1 over 10. Next, part B of the question, from this, the same experiment, what is the experimental probability of getting a 4? So we need to get the probability of getting a 4 in our experiment. So we find out how many times has the 4 occurred in our statement. And we discover that the 4 has occurred 1, 2, 3, 4. So 4 has occurred 4 times. So probability of 4 showing is number of outcomes, or the number of times the 4 has shown, which is 4 times, divided by the total number of trials, which is 10. So we are having 4 over 10. We can simplify the 4 over 10 to be 2 over 5. So part C of the question, it is asking us to get the experimental probability of getting an odd number. So in this case, you need to understand what is an odd number first. And an odd number is simply that number that is not divided by 2 fully. So we find out from this experiment which are the numbers that have shown up that are not fully divided by 2. And the first number we meet is 5. We have 1 and we have 3. So those are the odd numbers that are in this experiment. So we are having 3 occurrences for the odd number. So probability of getting an odd number, we have 3 occurrences for the odd numbers. Then out of the total number of trials, which was 10. So you get that the probability of getting an odd number in this situation will simply be 3 out of 10. In simple, we are having 3 odd numbers that are showing up in this experiment, and the total trials that were carried out were 10. So probability of getting an odd number will simply be 3/10. So we are having a survey is conducted on people's television viewing habits. So we have the number of hours in a week these people will view the television. Then we have the number of people. So between 0 and 5 in a week, we have 20 people. 5 to 10, we have 10. 10 to 20, there are 15. Then 20 to 30, we have 5. 30 plus 30 and above hours, they are 0. So the first question is, how many people participated in this survey? So we are having a survey that was carried out. So how many people have participated in this survey? So how do we get the number of people who have participated in the survey? We simply get the number of people who are grouped in this given survey. So we are having those people who are watching between 0 and 5 hours, between 5 and 10 hours, between 10 and 20 hours, between 20 and 30 hours, then 30 plus hours. So this number of people that are watching in each category will give us the number of people who participated in this survey. So the number of people who participated in the survey is 20 plus 10 plus 15 plus 5 plus 0. So we get 10 plus 20, that is 30. 30 plus 15, 45. 45 plus 5, that is 50. 50 plus 0, it is simply 50. So we get that 50 people participated in the survey. So we are having 50 people participating in this survey. The next question . So the next question is, what is the probability that a randomly selected participant watched less than 5 hours of the television? So we are having the number of hours between 0 and 5. That means these are the participants who watched between 0 and 5. It means that they could have not watched, or they could have watched for 1 hour, they could have watched for 2 hours, 3 hours, or 4 hours, the numbers that are between 0 and 5. So what does it mean? So those people who watched for less than 5 hours will be obtained in our first category, where you are having 0 to 5. So the number of people who watched for less than 5 hours were 20. These are the number of people in this survey that watched for less than 5 hours. So if the number of people in this survey that watched for less than 5 hours are 20, our total number of people who were surveyed was 50. So what does it mean? Probability of people who watched for less than 5 hours will simply be obtained by the number that is the number of times, or the number of people who watched for the less than 5 hours, which is 20, divided by the total number of people in the survey, which was 50. So if I simplify this fraction, then we get that the 0 cancels out and we are left with 2/5 as the probability of those people who watched for less than 5 hours. So the next question is, what is the probability that a randomly selected participant watched between 20 and 30 hours of the television? So which participants, how many participants were in that category? You find that the number of participants in that category were 5. So we get that the probability of those people who are between 20 and 30 hours, we are having 5, then the total number of participants who are in the survey were 50. So we get that the probability will be 5 out of 50. Then simplify our fraction. 5/50 is just the same as 1/10. So we get that the probability of those people who watched between 20 to 30 hours in that given week were 1/10. Part D of the question, what is the probability that a randomly selected participant watches between So our question now lies between 5 and 20 hours of our television viewing. So we are having between 5 and 10, then we have 10 and 20. Between 5 and 10, we are having 10 participants. Those who watch between 5 and 10 hours, we have 10 participants. Then those who watch between 10 and 20 hours, we have 15 participants. So these are the group of people who will give us the number of people who will watch between 5 and 20 hours. So between 5 and 20 hours, we discover that in the first group we have 10, then in the second group we have 15. So the total number of people who watch between 5 and 10 hours is simply 25. Then the probability of those people who are between 5 and 20 hours will be obtained by the number of people who watch between 5 and 20 hours, which is 25, divided by the total number of people in the survey, which were 50. So that means that the people who watched between 5 and 20 hours will be 25/50, which can be simplified to give us a half. So this is the question that we ask ourselves at the end of this survey. We discover that from the survey, you find that for the 30 plus hours in that given week, for those people who were interviewed, there was none who watched the television for 30 plus hours. So the question is, does it really mean that in real life situation, there is no one completely who can watch the television in a week for 30 plus hours. And the answer is no, because this is just these people in this interview. But in real life situation, there is a possibility of finding a person who can watch this television for 30 plus hours in a week. But the people who were in this survey, none of them was watching the television for 30 plus hours in a week. So what does it mean? In experimental probability, the answers we obtain might be slightly different from the actual situation on the ground. It doesn't really reflect what is on the ground, but what will happen is the answer is closer to whatever is happening on the ground. That there could be people who are watching 30 plus hours, but there are very few of them. Meaning, you could, maybe people are occupied by other activities and they have very minimum time for watching the television, such that their time in which they are watching the television cannot add up to the 30 plus hours. But there is a possibility that there is a person who is just there and most of his work is just watching that television. So it means there is a possibility that you will get 1 or 2 people on the ground who are watching this television for 30 plus hours. So experimental probability just gives us a reflection of whatever is happening on the ground. So as you are carrying out the experiment, you are in a position to tell what is really happening on this ground. Or you get a picture, you get at least to have some knowledge of whatever to be expected on that given activity that you've carried out. Another example on experimental probability So we have a question. The color of cars in a school car park is recorded as follows. So we have color and number of cars. Red are 21, black 24, white 25, blue 20, purple 3, then green 7. Then we are being asked, basing on this sample that we have, what is the probability that a randomly chosen car is white? So from this sample that we are having, we need to get the probability of choosing a white car from this sample. So what we need to find is the total number of cars in this given car park. So this car park, we need to get what is the total number of cars. So the total number of cars, we have 21 plus 24, which gives us 45. 45 plus 25, that is 70. 70 plus 20, that is 90. 90 plus 3, 93. 93 plus 7, we have a total of 100 cars. So the probability that a car chosen randomly will be a white car, then it means that the number of times the white car is appearing over the total number of cars we have. So the number of times the white car is appearing in this situation is 25. So we are having 25 white cars. So it means probability of picking white car from this sample will be 25. Then the total number of cars in this situation is 100. So we are having probability of a car picked being white will be 25 over 100. If we simplify 25 over 100, then we are simply getting 1 over 4. So the next question is that what is the probability that a car chosen randomly will be a purple car? So in this situation, we find the number of cars that are purple in color, which is 3. So probability that the car chosen is purple is that we are having 3 purple cars out of a total number of cars, which is 100. So probability that the car chosen at random from this car park will be of purple color, then it is 3/100. Part C of the question, we are being asked to find the probability that a car chosen randomly is either green or black. So green or black. We are having 2 options, that this car that is chosen will either have the color green or it will have the color black. So we find out how many cars in this car park are of the color black and how many cars are of the color green. So that means we are finding the probability that the car is green or the car is black. So we have 2 options. The car could either be green or the car could be black. So this means that we have the probability of the car being green, which is there 7 green cars, so that is 7/100. Then we have 24 black cars, so we'll have 24/100. Then we add the 2 fractions, 7/100 plus 24/100, that gives us 31/100. So the probability that the car picked will either be green or black is 31/100. Question 4, we have So this is a survey that is being carried out, another experiment that has been carried out on number of children in some families. Then it is recorded in this table. We are having 5 families that have 0 children, 20 families have 1 children, 32 have 2 children, then 10 have 3, and 3 have 4 children. So from that table. Then the first question is, how many families have no children from our survey? We find that from this survey, the number of families that does not have children is 5. So we find that 5 families has no children. The second question, so the next question is, how many families have even number of children? By even number of children, even number, we mean that a number that is fully divided by 2. So we find that in this case, the even number of children, the first we have 2, and the even number of children also in that case we have 4. So we find out how many families have even number of children. So it is either that family that has 2 children or the family that has 4 children. So in this case, families that have 2 children are 32. Then families that have 4 children are 3. So the total number of families that have an even number of children is 32 plus 3, which gives us 35. So how many families participated in the survey? 5 families that participated is 0, so we have 5. Then we have 20 families that participated had 1, so that is 20 families, so we have 5 plus 20. Then we have plus 32 plus 10 plus 3 to get the total number of families that participated in this survey. So 5 plus 20, that is 25. 25 plus 32, we are getting, so we have 25 plus 32, we are getting 57. 57 plus 10, that is 67. 67 plus 3, we get 70. So the number of families that participated in this survey is 70. So from this experiment, we are supposed to find the probability that the families that participated in this experiment or in this survey have either 1 or 2 children. So we get the probability that the family that participated, has 1 child, probability of 1 child from this experiment. Total number of families that participated are 70. So probability that the family that participated has 1 child. So families that had 1 child are 20. So probability that this family had 1 child is 20 over 70. Probability that this family has 2 children, we get that there are 32 families that had 2 children. So we'll have 32 over 70. So probability that this family has either 1 or 2, then it means that we will have 20 over 70 plus 32 over 70, which gives us 52 over 70. And when that is simplified, we get that 2 into 52, that will be 26. Then 2 into 70, that is 35. So the number of families, the probability that the number of families have either 1 or 2 children is 26 over 35. So this is experimental probability that we've been looking at. You can carry out an experiment in various sections of life. We just said that maybe you want to start up a business and you need to find out what is the probability of either getting a loss or a profit in that given business that you want to start. So what will happen is you can go ahead and carry out an experiment on people who have already started that type of business that you want to start, find out of those group of people that have that given business, how many have made profit, how many have made a loss. Then from there you are in a position to calculate what is the probability that if you go ahead and start that given business, you are most likely to get a profit or you are most likely to get a loss. So given the knowledge on experimental probability, it is very much practical and it is very much important to us because it will help us in our day-to-day life. Thank you for listening and enjoy the rest of your day.